like this. Alrighty then. Shall we carry on with atoms?
Yes.
Yay! Let's share the screen. Seriously, I hope. If you'll excuse me, I will have to. Let's see if it works. If it doesn't, then we're going to have to restart the computer. Um, just a minute.
Okay.
Shared my screen. Okay. It told me to renew my license, but I promise you I do have one. Uh, for some reason, it just gets kind of lost. Yeah, I can also draw, and it doesn't draw anything. But okay, I was just checking. I will rearm it. If you have any issues on Windows with the reactivation of your trial period or license period or anything of the sort, there's a command you can write into command prompt as administrator, and it
Mhm.
should immediately renew the license. I have it saved. I got it from my Iranian kids, and when I find it, I will send it to you. I promise, because I think it's necessary. Oh, there we go. Found it.
Okay.
Just a moment. There you have it. Command prompt as admin read the office or window. Sysadmins oftentimes use this. I'm just gonna I'm just gonna nail it here somehow. I don't know how you do that. Pin it, yeah, pin. Yeah. It's good to have because it can be embarrassing. You're trying to hold a lecture and the whole thing goes like I don't want to work. And I'm also teaching at McDaniel, and I love the
Yeah.
place. I love the atmosphere, and I love the people. And one of these big bearded boys from Iran, he's from the Lot people. They're called that. He has these ears and eyes, and he's quite unique in his appearance. And he's a hoot and a half. His name is Ali. He told me,
Okay.
"Sir, will you allow me to solve this?" I'm like, are you sure? He's like, it's not particularly common, or I'm not sure if it's legal, but it should work. I'm like, go ahead, do your Persian magic. And he taught me this command. Yep. Then you just navigate the black window and it rearms, reactivates everything with your own credentials. For some reason, I don't know why, some of these may get lost or some antiviruses may detect it as something wrong. Do you use a Mac or a PC primarily?
A Mac.
Oh, perfect. With Mac, you don't have these issues. Okay. But let's say you're presenting on a PC and these issues occur. You have this, you write in the command. People are going to be super impressed because you gained administrator rights. And then you're like, wow. Yeah. Uh, we're just going to have subatomic particles, atomic number, mass number, isotopes, ions, relative atomic masses, and radioisotope applications. But really briefly, it's in greater detail in the Stoker book, but it's not going to be, all the others are not going to be in this topic because it's going to be part of a further topic. So that's how I did this. Obviously, you know what a proton, a neutron, and an electron is and their particular charges. And you know that the electron is present in the form of a cloud. Uh, Usually in the Hungarian system, we go into these great details about um, how various atom models came about. Some people really enjoy science history. I think there was a prime minister of Hungary by the name of Antal József. He was fascinated by medical scientific history, and he was quite good at it, actually. He was a great author in that field, indeed. However, it's not what he's known for, unfortunately, because he was really good at it. Yes, he was the first prime minister of modern day Hungary after the well, fall of communism. I don't know if it actually fell or got rebranded, but you know how it is.
Yeah.
People in the region have this great amount of melancholy about them, but for reasons. But yeah, you ask anyone, they're gonna say various things, depending on how what situation they're in. Now, atoms, the word atom, what does it mean? Where does it come from?
Latin.
Latin or Greek? Yeah, it's usually those two. Atom is from Greek, actually. The Greeks came up with things, and the Romans improved upon it. Yes. And oftentimes there's a fake kind of beef between them, kind of a fight. Who's better? And obviously they love teasing each other. But yeah, the Greeks don't really get along with their neighbors, do they? I mean, the Turks hate them with a passion. I mean, it's understandable because obviously through the Islamic conquest of Constantinople, actually Christian Greece became Muslim. Yeah. The oldest bread that was ever found, baked bread, probably a proper leavened bread, actually comes from the Anatolia region of Turkey. It was just recently
Lemon
found.
bread.
Yeah, 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 baked bread, and it has an image of Jesus, and it was communion bread. So, yeah, uh, we were taught back in the day because we received a communist-like education that the church is bad. I mean, obviously, any big organization does bad things. If it grows big enough, it prostitutes itself. That's 100% true. But you have to put everything on scale in the long run. I mean, hurting people is bad, but if they want to enslave you, I kind of get it. So
Mm,
yeah,
yeah.
it's always not that simple. It's always multifaceted, complicated, nuanced, but ideologues don't like nuance. They don't like it that most of our history sucked. We suck, so we need to improve. That's the
Yeah.
bottom line. And there's no nobility in being a bad person. Yes.
Yeah.
Now, the atomic number is going to tell me the position of an element because a guy called Dmitry Mendeleev was brave enough to make sense of it all. Because it took bravery. I mean, if you think about it, greatest philosophers, greatest innovators, they were beyond anyone else in intelligence. Oftentimes they were not understood. Oftentimes they were considered insane, like Semmelweis, for example. He was
Yeah.
considered insane for the time period because it was so offensive to say, "Oh, wash your hands, Mr. Medical Doctor. Why? Because you're dirty." Me dirty, but I'm a gentleman. You can be a gentleman and spread infection. Yeah, I mean, there are people even nowadays who say they would rather not go to a hospital because they don't want to catch an in-hospital-borne disease. It's called nosocomial infections, and it's not gone. Some hospitals, even in Hungary, they still suffer from it, oddly enough. Yes, in this
Okay.
day and age, and not just Hungary, even other countries. Yes. Um, Now we have to distinguish between an element, an isotope, and a radioisotope because they're different things. Yes, an element has the same atomic number. Oftentimes we confuse atomic number with mass number. Have you noticed this? People whose
Yes.
first language is not English, I confuse the hell out of it. Heck, even native speakers oftentimes they confuse it.
Hmm.
Even people who are called a boffin after completing a bachelor's degree. What's going on? There's something going on. What's going on? Zoom. I wish we wouldn't have these unfortunate mishaps, but uh, yeah, certain softwares need to be better written. And I'm being nice. An isotope is going to have a different number of neutrons. So certain elements might have other forms present in nature or artificially created. For example, cesium-137 cesium-137 will only be present if there was some wrongdoing. If I'm able to measure it from the environment, there was something suspicious going on, and we can be sure that someone did something irresponsible,
Mhm.
looking at you, this or that government or this or that irresponsible institution that wasn't properly guarding radioisotopes. Yes,
Mhm.
because it shouldn't and it cannot be present in nature in any way because it's a strictly artificial element. Even certain uranium isotopes cannot be present in such high amounts on a metro, on the street, or anywhere else unless it's been artificially created and there is some foul play afoot. Now,
Mhm.
if you're interested in your surroundings and radionuclides, you can get a hobby device, which is more or less for educational purposes and basically civilian science. It's called a radio code device.
Okay.
The radio
And what
code
is
device, I can show you one because I I have one by
Oh, isn't
chance.
that what you said that you once like tried on the metro or something?
Yeah,
Or
yeah, yeah. And I actually measured the high levels of background radiation, and they did catch terrorists. Apparently, were trying to smuggle radioisotopes. I don't know where, not my business, but tech actually caught them. Tech first investigated me if I was paranoid schizophrenic, and I'm just pulling the whole thing out of my bum. They tried to calm me down. They said it's probably technetium-99. I showed them that you can easily get technetium-99 and this in this laboratory, and this is also a scintillator, and it will show you that it's technetium-99M, which is used for medical purposes exclusively. I can tell on a metro who's a chemotherapy patient, who's a cancer patient, and who receives radiotherapy, and how much of it gets dissipated in the surroundings, and should little children be near it. Why? Because this is my hobby. I measure background radiation around me. I take various parts in order to make sure that everybody's safe. Why? Because I do not trust a lot of organizations to do an effective work. Afterwards, the International Nuclear Committee, or what's it called, my friend Tom Roberts is its president. They actually had a conference in Budapest, and they have strengthened nuclear safety throughout Europe, so terrorists won't be able to smuggle radioisotopes to make dirty bombs. Because these radioisotopes, you don't notice them. They're in your surroundings, and let's say an entire part of a town might get thyroid cancer or some other type of cancer just by being exposed to them. Not to mention polonium. Yeah. You don't drink matcha tea with Vladimir Putin because it may be laced with polonium. And polonium is a sneaky one because it's an alpha emitter. And it's much more difficult to detect alpha emitters than gamma emitting isotopes. Alpha isotopes are not dangerous if they're outside the body. However, if they're inside your body, they're super carcinogenic. We will learn about that later on. And this concept of isotopes and radioisotopes is going to explain why periodic table atomic masses are actually decimal values. And there you can see the isotopes of chlorine and their relative abundance in nature.
Mhm.
It was a long road till we got here as a species, but it's rather amazing. Nuclear reactions did occur by accident in some places on planet Earth. There are places in France where water boils due to nuclear reactions on the ground. It's not radioactive water, it is something that naturally has occurred. And obviously, politicians nowadays who've got all of their information about nuclear from The Simpsons, which is a cartoon series. I'm saying that because not a lot of younger people know The Simpsons anymore. Yeah, today I saw a meme. Those guys with whom I've been to rock concerts, headbanging and screaming and drinking all the beer. How are your tomatoes doing? You're old. Yeah. Be like a proton, be positive. You may have seen memes like that. Usually I get those random chemistry memes. Protons define elemental identity. Have you heard the term transmutation?
I think I might have. Uh,
Sounds mysterious, doesn't it?
mhm,
It sounds like magic. Because it is. You can turn one element into the other.
mhm,
If you've heard of alchemy, alchemy was an ancient practice. It was a hermetic practice. Alchemia means in Old Arabic the art of transformation. Now, does it mean that Arabs were the pinnacle of science? Not at all. It means they have usurped the Iranians, and obviously, despite Arabic rule and Arabic Muslim conquest, the creativity and the pure genius of Persia could not be diminished. And despite that, they have created the so-called Golden Age of Islam. Distillation comes from Persians, the great nation of Hungary. Thanks, you guys. We wouldn't have Palinko without you fuckers.
mhm.
But yes, a lot of discoveries do come from there. Even the term chemistry, alchemia means the art. Yes, and of course, it has changed from language to language, and alchemy itself was used for medicinal purposes, but also a lot of techniques come from alchemy. We've inherited it.
Mhm.
And the ultimate goal was to transmute one element into the other, from cheaper elements, create gold, virtually, and to find the philosopher's stone, which is the ultimate medicine. So it always had a medicinal background, but it did do a lot of bogus things like traditional Chinese medicine did. It was quackery, oftentimes. I mean, many emperors, Chinese emperors, and also European royalties were supplemented with toxic heavy elements, due to which their health dramatically deteriorated. Or if someone had syphilis, they were told to bathe in mercury. Mercury was deemed beneficial because if you would decompose its oxide, it would turn into a liquid. And how magical is that? It can change its state. Wow. Uh, yeah. People thought weird things. And by the way, nowadays we know that these heavy metals can oftentimes exchange calcium or have special chemical bonds with proteins in your body, which over time and over bioaccumulation can have detrimental effects on health, on psychological health, and lifespan, and fertility, and the whole 9 yards. So,
Yeah.
yes. My dad is full of heavy metals. Me, I have heavy metals, microplastics, radioisotopes. My son, I hope he's free from all of these. I hope, and I hope so are you. I mean, oftentimes we try to avoid bacterial infection at a price of other things. And was it that people previously were stupid, or were they evil? No, they didn't know better. They solved the problem with what they've used in abundance, but they didn't know that solving one problem created a plethora of others. So it is how science is.
Yeah.
Of course, the relative mass of an electron is going to be negligible, which is with its negative one charge, and a neutron, as the name says, is going to be neutral. We're just going into subatomic particles. We're not going to go any lower because it isn't quantum physics. I would love to, by the way, because I could talk about this all day. You probably have seen already. But
Mhm.
this is what we must know. And when you imagine an atom, imagine a bee swarm around the central point like nucleus, the bee swarm being the electron cloud, occupying certain areas with high probability. High probability doesn't always mean 100%. Yes, it's very probable that I'm on the other side of this, but I could be on the moon and use special technology just to stay connected for all we know, right? No, no, there would be a delay. We would have to use quantum entanglement to not have delays in communication. By the way, we do have that technology. It's just not widely available. Uh,
Mhm.
yeah. Quantum entanglement means that if two particles are entangled, if I'm exciting one of them, the other one is also going to react, and it's kind of like a Morse code.
Particle entanglement, you
Yes,
said?
ma'am. Particle entanglement. It's quantum entanglement. Yes. Two particles being born at the same time, you do something to one, the other one's gonna feel it. It's kind of like the whole stereotype about twins. Yes. Yeah, yeah, and it's rather wonderful. It does enable long distance communication with no delay. However, it's still under research, and if it's not widely used, it means it cannot be marketed, or it shouldn't be marketed because of you cannot put a price tag on it or a meter on it. Oftentimes, great inventions fail at that. You just have to buy one, and then what? You're done. Yeah, but if it's good enough technology, it may be worth a try. I don't know. There are some strange things that never become products, while other things do, because their mass production becomes profitable. Like with mobile phones, for example, they had Motorola phones back in the day in Vietnam. Well, there were radio phones, but worked in a similar fashion as they did in the 80s and in the 90s. They became more widely available, and nowadays you can't really imagine anyone without a mobile phone, even if it's an old one. Yes. Now, obviously, the protons define the element, the neutrons define the isotope, and the electrons are going to define the charge. Is it a positive? Is it a negative charge? Obviously, oxide ions can be mono or divalent. It depends on on the amount of electrons taken. And if you change the number of protons, well, you're talking about a new element. You have done transmutation. Yes. One of the ultimate goals of alchemy was actually turning lead into gold. Um, there have been articles circulating in the trash media about actually achieving transmutation. If that were true, then obviously the sheer amount of gold would have changed on planet Earth. It remains rather constant because its scarcity gives it value. Same is true with diamonds. Nowadays, artificial diamonds can be created, and the price of diamonds are being kept up artificially. True laws and regulations. It is what it is. First artificial diamonds were made in Russia. Well, Soviet Union, then it became Russian Federation, and actually they had a wonderful discovery which couldn't be marketed under communism. So yeah, a colonel from the US Army actually bought the scientists from the Soviet Union or Russian Federation because they haven't received their salaries for 6 months. So yeah, this guy took their families and these guys and shipped them off to Texas, where they started making their first artificial diamonds. And nowadays, around 25% of jewelry diamonds are cheaper because they're artificial, they're not natural diamonds. How can you tell by proper investigation? If the bubbles are quite uniform, you can be sure it's an artificial diamond. If they're more random, then
What do you mean
often
by bubbles?
bubbles get trapped when carbon gets compressed by
Okay.
huge masses of land. And if it's asymmetric, if it's not uniform, then it's natural. If it's quite uniform, you can be sure it's artificial. But it's
Okay.
possible. It's possible. First ones were kind of dark, kind of weird looking. The new ones, oh, they're remarkably pretty, and then they're remarkably good. So
Mm-hmm.
yeah, it's an interesting topic, anyways. Um, an atom can have no neutrons and still have an identity, and obviously hydrogen minus one is quite an important exemption from that. It's hydrogen plus one, hydrogen minus one are both possible as
Mm-hmm.
um, as ions, but hydrogen one usually, yeah, it just has a proton and it is what it is. But of course, it has several isotopes as well. Atomic number is going to define chemical identity, and you'll spot in the periodic table invented by our old friend, the big bearded guy, Dmitri Mendeleev. Actually, the guy himself, he wasn't the first one to come up with a periodic table. He was the first to publish. There was a German dude who was kind of scared to publish it. His name was Lothar Meyer, and he also made a periodic table. I mean, it was obvious. It was in the air. It was in the 1860s. Dmitri himself was an animal. I mean, he walked from St. Petersburg to Moscow because he wasn't admitted on the first go. He walked by foot. It was common back in the day for poor people to walk absolutely huge distances. And since they were poor, how do you think they survived?
What do you mean, like the walk?
Yeah, the walk, where did they sleep? I mean, they didn't have money for a hotel.
Probably on the ground.
Yeah, sometimes on the ground, but oftentimes people would just take them off the street, or priests
Mm,
would actually help them. And
yeah.
there's a custom as well. Usually in Polish families around Christmas, usually there's an empty spot reserved. If someone comes to your home, you have to take them in because it's kind of like the whole Jesus and Christianity thing, because Jesus's family was like that, and yeah, you'd
Uh-huh.
probably take them in, but these people didn't cause a ruckus, they didn't cause any problems, they wouldn't misbehave, they would rather be nice and lead by good behavior, because how are you going to be perceived? According to how you behave. I mean, even in a lot of Eastern countries nowadays, if you're a foreigner, many Russians are going to be suspicious of you, but they will also try to be kind to you if you speak a few words. Same is true in China. Same is true in many countries. And these people are poor. They're not particularly rich, but they're going to share what they have with you.
Uh-huh.
Even though you don't look Chinese, you don't look Russian, you don't look like one of them, they're going to ask you, what are you doing there? What's your goal? If you're interested in their culture, you want to learn their language, you're trying to be polite to them, you got yourself a win. Yeah, because people are people everywhere, and they're much more curious than xenophobic or racist or anything of the sort. You're not going to make any friends if you misbehave. I think that's the whole thing about this being a stranger thing. If you misbehave, or a lot of people who come from your region misbehave, you're not going to earn yourself too many friends. I mean, I've seen the building industry in Hungary, and a lot of mankind did not behave particularly well. I mean, one of them was complaining to me that, oh, they hate me because I'm a Transylvanian Hungarian. I think that's why they told on me to the boss that I'm smoking marijuana while working. I mean, yeah, it's probably your identity. That was the issue, not you using an illicit substance on the job. That was beneficial. They would have given you a raise if you were a local. I mean,
Oh my God.
yeah. I've also got this when I was a dorm teacher that I hate Hungarians from beyond the borders because I'm hateful. I'm like, yes, I hate my mother, I hate my father, my grandparents, my entire lineage, to be honest. And I
Obviously.
really hate this kind of behavior. I mean, obviously, I've meant it as a powerfully sarcastic joke. But sometimes you get accused of racism if someone of a slightly different tint in comparison to you misbehaves, and you hold them accountable. See, it's an accountability game. Don't fall into this. Hold everyone to the same standards, and be thorough in having them obey these rules that apply to absolutely everybody the same way. Yeah, you might hear things like this that, oh, locals have it easy, or locals are going to say internationals have it easy because they have a lot of money. No, they do not. Nobody has a lot of money as a student. I've never heard of such a thing that, oh, you know what? That small child, he's really well behaved. You're not going to hear that. Or that really old woman, she's really pretty. I hope she's going to give birth soon. You're never going to hear that, yeah? And it's kind of like that with rich students as well. Usually it's not. Oftentimes, these international kids, they come with a lot of money because they cannot afford bank transfers because their country is on some kind of blacklist, and they left their country why in order to study in relative freedom and in relative better opportunities, especially in English, in a more international and more connected environment. And a lot of times people don't understand this, and you have to be aware of these feelings, I guess, because people can be a little scary in their ill-informed, low IQ mannerisms. And for you, it's difficult to understand because you're a smart person and you've already met several cultures.
Hmm.
So yeah, don't have a culture shock like I did.
Yeah.
If you change the number of protons, you're going to have a new element. Just by changing the number of neutrons, you're going to have a new isotope. Yeah. For a neutral atom, it's perfectly easy. Number of protons, number of electrons are the same. No charge. And this rule does not apply to ions because ions, they always want to have a charge. Mass number comes from number of protons and number of
Electron.
neutrons.
No chance. Yes, yes.
Yeah,
Yes.
electrons, my
No, no,
my
that's what I meant.
carbon 14, oxygen 16, sodium 23. These are all isotopes. Sodium 23 is the most abundant isotope of sodium. If there's something else being present, it may be a radioisotope and it may be a byproduct of something else. I usually look for daughter nuclides from decomposed elements. That is how I'm able to detect radon and radium isotopes. I mean, the specialist they sent me from tech, he said that you cannot detect radon. I said, no, you cannot detect it directly with a scintillator, but you can detect its daughter nuclides and deduce that this was radon actually. And uranium is not a daughter nuclide of radon. So, it appears the specialist was a little bit confused, and they also sent a psychologist to see if I was insane. And I told them that I do understand. I mean, they also did the thing, that police do when they interrogate you. They make a silly gesture, like they give themselves horns or put their thumb on their nose and move their fingers, wiggle them as if they were like teasing you. And if you focus on your story and you don't call them out on it, it means that you're trying to sell a story and you're not telling the truth. It's kind of like trying to tell methanol from ethanol apart. Yeah, it's weird. It's weird when you're trying to protect others and the people who were supposed to do the same. First they confront you and instead of doing that job. But they probably have their protocol and they do have their reasons. I respect what they do. It just seemed odd. Have you ever been arrested?
No.
I have, but
Oh,
because the people were breaking in by and they just questioned me. They wanted to take our fingerprints. I said I refused because I committed no crime. Then they signed a waiver that they're going to throw it out from the database once they checked. And I did hold them accountable to it. Yeah.
so did you let them?
Oh, yes. Afterwards, yes, of course, 100%. I want them to find the culprits, but I'm not on record.
Okay, okay.
But also nowadays you have to give a fingerprint in European Union passports. So
Yeah.
yeah, they don't want a DNA sample or something instead. It's like really silly, but it can be useful. Can be useful. I have a friend, Amir Pasha Hadassi. He's a great kid. He's a tall guy. He looks like an Iranian wrestler because his older brother Parsa is indeed a wrestler, an honorable man. Both of them are honorable young men. And Amir Pasha was stopped in Turkey, and he was withheld for an entire night for interrogation because an international terrorist by the same name looked the same way. He was just shorter than he is. And his
Oh,
dad was already laughing. He's like, my son, the terrorist, again. So he got a European passport since, and I think he has a Swedish citizenship in which he has his fingerprint, and that's that way he's okay. Uh, uh,
okay.
Yeah, a lot of these boys oftentimes come away from home as if they were children. Their mothers do everything for them. I had to teach them how to iron shirts, clean a home, wash dishes, cook. He learned it. He learned it at the age of 17 because he was so helpless. I helped them pick out a suit to get admitted to uni. He got admitted to Semmelweis. I think he already finished last year. He defended his thesis. A lot of my kids have already finished uni. A lot of them are practicing medical professionals. And he said, oftentimes people who migrate from these strictly Muslim countries, they can't really cope with the freedoms they get, especially boys. If the dads are not there to beat their asses for misbehaving, they feel like there's no laws. And he said they're just being stupid. They're not being terrorists or anything of the sort, but oftentimes they do stupid things. So you kind of need that parental and community control for them because they can't really handle the freedoms they've got. I mean, what I see, kids your age, you may misbehave, be a bit noisy, sometimes drink, but I don't see doing stupid things like lighting things on fire, causing mass accidents, or I don't know, really dumb things that may happen in regions where there's a high concentration of youth without proper dads. It's as
Mhm.
simple as that because sometimes they say, "Oh, it's race, religion." I mean, religion and where you come from. If you come from a dictatorial regime and all of a sudden you got freedom, you think crime is legal. It's not. Pasha knows this. Pasha's a great kid. I mean, he's been a student representative. He did amazingly well. Yeah. I'm telling you this just so to know oftentimes what to expect, because
Okay.
it's not like the good or bad people, that different, and being different is fine if we go by the same rules and we apply the same requirements towards everyone in behavior and in scientific achievement. I also teach a princess at the Faculty of Health Sciences. His father is a chieftain.
Princess?
Yeah, yeah, her name is Princess actually. Yeah,
Oh, okay.
and she works in a factory while studying
Oh,
because she's
okay.
from Africa.
Hmm.
At home, she's a princess. In Hungary, she has to work in order to afford the cost of living and the tuition fees.
Wow.
And she's studying to become an optometrist because poor eyesight is a huge issue in Africa and it's an ignored issue.
Hmm.
Yeah. Now we're counting neutrons. Why? Because that is what defines isotopes. They're in the nucleus, there's no charge. However, nuclear stability is well defined by the proportion of protons and neutrons because nuclear forces hold them together. Yes.
Hmm.
Uh, so oftentimes the difference between atomic number and mass number is going to give you the number of neutrons. How do you know that a nuclear mass number to the top left corner,
Yeah.
atomic number, lower left corner, charge, top right corner.
Why is the atomic number always Z?
Oh, I don't know where the Z comes from, actually. I never questioned it. Could it be some kind of German word? I suppose. I
Maybe.
don't know. Wow. I always learn from you. That was wow. I'll look it up and message you back, okay? Why
Okay.
is it dead? I have no idea. I never actually questioned it. Um, a lot of my colleagues had these interesting questions as well that they had in the seventh grade when they started chemistry, and they were always afraid to ask, and they just accepted it. And I was like, but why is it that? I mean, A obviously from the atom, but Z. Hmm. I don't know what expression does it come from. Usually, with a lot of chemistry expressions, it's going to be something of German origin because in the 19th century, German-speaking people were at the pinnacle of the science itself. Angewandte Chemie to this day is a high impact scientific journal. Nowadays, the highest impact journals are in the US. Why? Because that's where the freedom of thought used to thrive or still thrives. I don't know. I don't know because there's a lot of political nonsense going on, and I don't think you should. Limit thought in any way, especially in science. Obviously, you have to put limitations where you can physically hurt someone. But if I don't want to listen to someone, I just don't listen and walk away because I can. Yeah? It's called being an adult. I mean, if I see something on Instagram or Facebook, Facebook is used by old people nowadays. They're bitching about how bad the world is. But yeah, Instagram or TikTok, if I don't like it, I just press a button, not interested, and I won't see it anymore. So what's the big deal? People say, oh, cyberbullying is such a thing. Dude, you can actually ban people from your social media
Yeah.
if you use it. I became poisoned by Instagram due to the fact that I teach high school kids, and yeah, they send you random reels. But in the case of boys, it's a way to connect. Um, and if kids invite you in their environment, you should probably go because it's a level of trust and it's a kind of connection. You don't have to like it, you just got to make the connection so you'd understand them more, I
Mhm.
guess. Yeah. The element symbol itself comes from short Latin words oftentimes, and it was proposed by Berzelius. A lot of great scientists were really questionable people. Well, by questionable, I mean they were assholes. Isaac Newton invented calculus and died a virgin. You know what? He deserved it. He was a prick. No, he abused his power in order to not allow other scientists to publish or stole other people's research. And still, he's widely celebrated. And I mean, obviously, you have to make an exemption between you have to make a differentiation between someone's scientific merit and merit as a human being. As a human being and as a scientist, I can wholeheartedly respect recent Nobel laureates from Hungary, like Koriko Katalin. She's a great person and she's also a great scientist. I've met her quite a few times. She did attend a few of my classes. By accident, she was waiting for a colleague. I didn't know who she was, and she wasn't even a big deal in the media yet. And yeah, Senor Jorbert, he's the guy who basically elucidated the whole oxidative phosphorylation and before that the citric acid cycle, which is oftentimes called the Krebs cycle in Western books. We go with Szentgyörgyi as well in Hungarian. I mean, it's understandable that they don't say Szentgyörgyi Krebs cycle in Western countries because it's a difficult Hungarian name. They have a hard time saying quite a few Hungarian names. It's not like names. It's not like it's Zoltán and that's it. Because Zoltán is fairly easy for Westerners to pronounce, right? But yeah, Senor is kind of difficult. He was always a
Mhm.
pacifist, a humanist, and an overall great guy and everyone says good things about him. His previous students also spied on him for the Hungarian communist government because that was the only way they were allowed to leave Hungary. And Senor, he understood and he said, you know what, I know what you have to do. I'm fine with it. I don't blame you for it. Imagine such greatness. I know you're spying on me. Go ahead.
Go ahead.
I have nothing to hide. I'm still the same guy if you're listening or you're not listening. And I do admire that kind of integrity. I mean, he would play volleyball with his students, he would ride a motorcycle, he would smoke in the laboratory. He was an avid pipe smoker. And yes, he kept campaigning for nuclear disarmament and world peace. It seems a bit naive, but at his level of intelligence, which is transcendental intelligence, let's face it, he had a really difficult time convincing heads of state to do behave. And he did meet quite a few heads of state. He was also trying to get Hungary out of World War II. Uh, he and his friends went to Constantinople at the time, and yeah, the whole thing failed because of traitors. They were seized by the Gestapo, the German, not German but Nazi secret police. Yeah. Well, I have various stories about him. My granddad knew him well, and yeah, my granddad also spoke a bit of Turkish and English and German and Russian. That's why I'm here.
Mhm.
Yeah, the more languages you know, the more cultures you're able to connect with, the more useful you are, and the more people you're able to come into contact with, and people are usually nice. Yes.
Mhm.
Carbon isotopes are quite remarkable because radiocarbon dating is going to tell you the age of a finding. Yes, these differences in mass obviously inhibit similar chemical behavior. However, the proportion of isotopes of carbon will tell you the age of a finding. That's how the Shroud of Turin has been assessed, and that's how dinosaur bones were oftentimes assessed. It's rather interesting. Hydrogen has three isotopes in nature. Tritium is also present in nature. However, the amount is negligible. If you have higher levels of tritium, well, if it's the Japanese letting tritium and deuterium-rich water into the sea, China's going to be up in arms and complaining. China does it routinely, but that's good. Their radioisotopes in nature are not dangerous. The Japanese is. They've been quarreling for millennia now. So, yeah, young people, they love each other's culture and they learn each other's language. Older people, they're trying to keep up old habits. Older Chinese are going to spit and say Japanese are dogs. Yeah, I mean, it's understandable there was a widespread massacre in World War II. And yes, the Imperial the Chinese army was not collecting for the Red Cross, believe me. But those times passed. Hopefully they're behind us. Yeah. And you do not nuke a country twice because Japanese do weird shit. Ever since. Yeah. Deuterium is heavy hydrogen. Heavy water can stop neutrons. It's used in nuclear reactors as well, heavy water. And nuclear reactors may produce tritium. Tritium is a radioisotope of hydrogen. I think its half-life is around 36, 37 years. It's an approximation. And tritium, as a gas, is oftentimes used in polymers, in special fluorescent polymers, because it keeps the polymer in an excited state and it glows. And it glows even without photons being nearby. It's basically a fluorescent site. That's how fluorescent sites work in American guns. Yes. Uh, if the half-life is 37 years, it means that, let's say, the brightness is going to reduce slightly. But in a lifetime, come on, in a human lifespan, that will last quite long. Is it radioactive? Slightly, not that dangerous. Just because something's radioactive, it doesn't mean it's deadly. Yeah?
Mhm.
Chlorine isotopes, I think um, we also did a few calculations here when we covered this topic. And obviously, isotopes form by gaining or losing electrons. If oxygen gains two electrons, it's going to become bigger. If something loses electrons, it's going to become smaller in radius and diameter. And changing the number of electrons makes an ion. Yes.
Yes.
And obviously, we have cations and anions. Usually more electronegative elements closer to the upper right-hand side of the periodic table, they're going to form anions. It's far more likely for them to form anions. Obviously, this is a theoretical experiment. If it loses an electron, if it's a cation, it gains one, and then it's a cation because it's positive.
Yes.
Chlorine has two isotopes in nature, and their relative abundances vary. This is why in the periodic table we're going to see an average atomic mass. There are a few worked examples here. They've given us the number of protons, number of neutrons, and we can determine the number of electrons according to charges. And these sorts of questions may come up in Moodle in the entrance exam. You have to complete a table, and the correct answers will be assessed accordingly. But since you don't write it with your hand, you write it with your keyboard, then obviously the right answers are going to be paramount. And charges are very important. What is the charge? Positive, negative. How do you write up a charge? Yes.
Mhm.
Relative to whom? Relative to carbon 12. 1/12 of the mass of carbon 12 is the atomic mass unit. Yes,
Mhm.
and this is why the mass number for chlorine is going to be 35.453 because of the two isotopes present in nature and their relative abundances. This has been measured, this has been established, and through decades of mass spectroscopy, elemental analysis, and everything, and through statistics, scientists have established this. Oftentimes, we consider a lot of things common knowledge, and we never analyze where does the standard actually come from. As you said with the Z thing.
Yeah.
So I never questioned it. I was like, that's what we call it. That's what it is. Well, and it's basically a weighted average. If you think about it, and obviously weighted average links isotopes to periodic table masses because uh, we calculate isotopes present in nature because some are man-made, some are going to be man-made. Carbon 12, 6 protons, 6 neutrons in its neutral state, obviously 6 electrons. And isotopic mass is measured in atomic mass units, and mass number versus atomic mass, the integer count isn't the same as the weighted average. Yeah,
Yes.
that's fairly important. And of course, it's not a mass number. It's basically the weighted average. The weighted average. Copper isotopes. There's two copper isotopes in nature as well. Again, the more abundant isotope is going to pull the average closer towards itself. Math kind of makes sense when you put it like that, right?
Yeah.
Because this is an issue oftentimes kids don't understand. Why do we learn this? What point does it have? Well, let's just show them in math. You can show a lot of amazing things. Um, the Pythagorean theorem can be easily explained just by walking. Yeah, you just go outside with kids and you walk, and you cut down the curb, and then you measure the footsteps. Easy. In school, you're given a formula, you're given a drawing. You have to remember that by next week or else. That helps. Yeah, it's like making an investment versus owning slaves. If you feel like you're investing in your future by accumulating knowledge, you're going to keep doing it. If you feel like you're being forced to do so, you're going to resist.
Yeah.
And as an educator, what can you do? You can just convince people to study. You can't really force them. And,
Yeah.
and obviously, in the case of isotopes, the radius is also going to reduce because protons are going to pull the electron cloud closer. There's a few exam traps. Particle counting is quite a trap. Um, always look out for the number of protons, neutrons, and electrons. It's like accounting. And of course, carbon has three isotopes present in nature. 12 and 13 are stable, and 14 is a radioisotope. It will decompose over time. And because we know its half-life, it helps in the identification of when a particular sample was alive and having a metabolism, because the proportion of other carbons and carbon 14 in a living organism is constant. While we're alive, we keep accumulating carbon 14. As soon as we died, we have no metabolism, so the proportion of carbon 14 is going to diminish. That's radiocarbon dating. Yeah.
Hmm.
And nuclide stability, obviously, protons and the proportion of protons and neutrons is going to define stability depending on the size of the element. We're going to talk in greater detail about this later. Radioactivity means spontaneous decay. Then what's the deal with radiation? Certain nuclides are going to decompose on their own because nuclear forces can't hold them together because of the proportions of protons to neutrons.
Hmm.
And again, in the Stoker book, you're going to find this in greater detail in the topic nuclear chemistry. For example, if it's a one-on-one proportion, it will be stable. But if it's a 1 to 1.5 at smaller elements, it's not going to work out. At bigger elements, that's beneficial. It's because of nuclear forces. Yes? Now,
Hmm.
radioactivity occurs because these nuclei they decompose, and as they decompose, you can have alpha radiation, where the mass number decreases by 4 and atomic number decreases by 2. Basically, it's like losing a helium, yeah, a helium 2 plus. At a beta radiation, it's going to be a minus. The mass number is unchanged. However, the atomic number increases by 1. And gamma radiation, both are unchanged, but energy is being released, and this is the highest energy. This can sterilize everything in all the meanings of the word sterile, if you know what I mean.
Hmm.
Um, under the communist era, because there was an overpopulation of Romanis, we call them gypsies, and they don't mind. I mean, I grew up amongst them, and usually this whole Romani thing, it's kind of like neutering the world to seem politically correct. But when you're sitting next to a brown person on the metro, clutching your handbag a little harder because they're brown. I don't judge people for being brown. That's bullshit. Behavior, yeah. If you misbehave, I'm gonna hate you. I don't care what you look like. So it's not about looks. And they call themselves gypsies. I mean, I've been called a gypsy. I don't mind it. When I was starting to teach at Avicenna, an elderly gypsy woman came up to me and said, Haziote. Oh, those letters E, they were like hugging me. He thought I was a musician. And I said, no, I teach. She said, where do you teach music? She was so proud of me because I looked the part and she was like, yes, you made it, son. It felt like walking up to your mother or grandmother. It was indeed a remarkable thing. Now with that being said, when they were the unlikables, communist regimes oftentimes sterilized them so they wouldn't have as many children. Yeah, they would have them fill out a form if they could write, and in the meantime, in the table they had a gamma emitter that would sterilize them, and they did this in various Middle Eastern countries to undesirables. Undesirables everywhere had this. Yeah, it's a crime against humanity, let's face it. But it can be used to friendlier things, for example, to disinfect medical equipment because it damages DNA.
Hmm.
Yeah, it's awful. Now, technetium 99M, yeah, that's the one. That's the one I can also detect on the tram. I'm sitting on the tram. My radio code goes like beep 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 in my headset. I'm like, okay, what is it? And I check on my phone and it's technetium 99M. Turn around, I see a pale woman looking concerned, looking really sad. Turns out she had a brain tumor and she was undergoing a PET scan and then radioisotopes were used for better imaging, and she's getting localized radiation treatment, and I told her that that is very localized, and you can return from that. So ask your doctors, be positive, be healthy, and do as you please because you can survive this. She was just really sad, to be honest. To go PET scan is basically positron emission tomography. It labels glucose with fluorine, and where there's higher brain activity, It may mean that there's some greater activity there. Iodine 131 is used in the thyroid therapy and imaging. Usually, it's liberated by the body and it decomposes quickly. For example, after Chernobyl, they have given iodine tablets to people. Have you heard of that?
Yes.
Well, they did that in order to make sure that bad iodine doesn't get accumulated by the thyroid. Bad times, yes.
Mm-hmm.
Now you can administer these radioisotopes linked to anything, and it's good for imaging. Technetium is also used as for imaging, and it's a good way to map physiology, and it doesn't strain the body as much as cutting it open. Now, obviously, you can easily fill this out. It's not difficult, right?
Mm-hmm.
Just a few questions. Those are for you. Um, Classify them if they're isotopes or not. There's a few pointers for an oral exam.
Mm-hmm.
There's a few mini tests as well with the answers as well. So usually the second part is for more proper revision.
Mm-hmm.
And yes, a lot of questions. Understand the counts and the vocabulary is obviously going to follow. With
Mm-hmm.
that being said, I'm also going to share the other PowerPoint as well. So let's get down to the nitty-gritty because I promised we would cover two topics today. I don't think you had any issues with this one, have you?
No, no, this one was good.
Yeah, I mean, these are quite simplistic for your intelligence because I've seen people struggle with various topics and oftentimes poor English and no chemistry background. You have a good background in natural sciences. We have something to build on. We have a foundation.
Mm-hmm.
Now, with the periodic table and all, we're going to um, we're going to just include a few new topics in comparison to the previous one. There's going to be distinguishing between shells, subshells, orbitals, capacities. It's going to be a tad bit difficult. Aufbau, Pauli, and Hans rule. Lots of German dudes. Hund actually means dog. I've learned just recently. Okay, I was like, why is it? Why was he called a dog? It's kind of a weird name for person. And of course, we will identify valence electrons likewise. I mean, sodium and potassium are paramount, calcium, magnesium, chlorine. Without them, we're cooked, right? Iron, zinc, iodine, they're very important as well. And so is copper. You'd be surprised. Your mitochondria won't function proper without copper. And if you have too much zinc, you might be lacking copper. So you have to mind your diet. Copper deficiency is not documented. Does it mean it doesn't exist? I don't know, because if it's not deadly, we won't recognize it in time. So, yeah,
Mm-hmm.
obviously, a wrong model would be this planetary model. A more accurate one would be the one on the picture. We use these diagrams in order to show that with very high likelihood those electrons are going to be there. But as you can see, they can be elsewhere as well, but far less likely. This uses probabilities from where?
What do you mean probabilities from where?
Probabilities. It uses probabilities from solving the Schrödinger equation. Because it's a
Ah, okay.
quantum mechanical model, yes, and
Mm-hmm.
the quantum mechanical model is the newest model. The Bohr model only worked for hydrogen, and that's it. Did
Yeah.
it apply a quantum mechanical model? Yes, but with postulates. Postulate. What is a postulate? If this is true, then that is true as well. That's inductive mathematical thinking, which has its merit, but usually, reality is far more fascinating and far more um,
Mm-hmm.
well defined than that. It's like drawing a stick man and calling it a man. Yeah, it's a symbol of a man, but is it accurate? No, not really. Yes. So it's not planet, it's likelihood.
Yes.
Likelihood of their presence. You have shells. subshells and orbitals. This comes from
Mhm.
the quantum mechanical model. One orbitals on the S, three orbitals on P, five orbitals on T, and seven in F. We shouldn't confuse shell number with the number of orbitals, and shells contain subshells, subshells contain orbitals, and each orbital can hold up to two electrons, and their shapes do vary. I had a fight with the AI. It just wouldn't understand that there are this many, and some of them have strange shapes. Yeah.
Mhm.
And yes, the Earths they can have really strange shapes. So can certain d orbitals as well. And yes, there's five of those likewise. And as you grow, just like in a cabbage or just like in the matryoshka dolls, you can fit more and more and more on the outermost shell. Yes,
Yeah.
you could. Do you know these Russian matryoshka dolls?
Yes.
Yeah, I think they're a lot of fun. You could actually buy Matryoshka dolls with Putin, Yeltsin, Gorbachev, and whatnot, and it was all the craze in the 90s. Anyone who went to Russia would come back with one of those. Um, yeah, it's kind of a satire towards its leaders, and yeah, I'm on board with that. I mean, certain people are going to get offended on their behalf. I don't know why. They're unfazed by it. This culture of being angry on my behalf is really alien to me. But uh, yeah, there are strange things. I mean, obviously, it's good to be considerate ultimately. You can have a number of shapes, and we call this a dumbbell shape. It could be a twisted balloon, whichever you like. And yes, in the case of alphabetals, it's super weird. Yeah, also DZ square. Look at that. It
Mhm.
looks like something out of the 17th century. Um, the capacity is going to be the number of orbitals times those two electrons per orbital. And this is
Mhm.
going to increase the more you move towards the outside. And S orbitals are going to be spherical, P dumbbell, the clover or really weird and rather complex in the case of F orbitals, and with size, other orbitals can fit in there.
Mhm.
And in the 5D subshell, well, d orbitals can only hold 10 electrons because it's going to be 5 times 2.
Mhm.
Electrons, they spin in opposite directions. Imagine the following. You're in a hotel and there's no lift. Well, you don't want to climb any stairs because electrons are negative and they're lazy and they hate their own kind the most. They could probably be some elderly residents of Budapest in that regard, because
Mhm.
I have these retired people say, that other guy, he's an asshole. They're both right about each other, by the way, but I love them dearly the way they are. It's just really strange how they are towards each other. But it's kind of a dynamic between them, I guess. Keeps them busy.
Mhm.
Now, obviously, the electrons are going to have an opposite spin because if they would collide, if they would have the same spin, they couldn't have the same spin because if one hits the other, it would give it momentum and it wouldn't stay in the orbital anymore. It's like a game of billiards.
Mhm.
And electrons occupy separate orbitals with parallel spins before powering up. However, parallel spin doesn't mean it's going to have an opposite one. If we have multiple orbitals, how are they going to be filled up? They're going to be pointing in the same
Mhm.
direction. Is oftentimes an exam error. All of them are going to point into the same direction. So opposite spin in on the same when they pair up. And if they don't have to climb any stairs, they don't have to climb an energy level. I mean the stairs as an analogy, then obviously they're going to stay on their own in the same room and they don't want to power up. I mean, you wouldn't want to be in the same room with a stranger in a hotel. Probably, what if they're snoring? Yeah, you might
Mhm.
not be able to catch any sleep. Yeah, I remember learning about this in quantum chemistry, and when one of my mates who's Romanian made a joke, "What if they're Romanian? They're going to steal your wallet." I'm like, "Shut the fuck up, Patrick." And he's actually Romanian, and I think he has a great grandma who's Hungarian, but um, he was just trying to lighten the mood, I guess. No, the self-deprecating humor is quite common amongst more educated people in order to burst stereotypes and bring people closer. But you need a level of intelligence to have that kind of understanding of things, because many people they go just linear, nothing more.
Mhm.
Aufbau. Do you speak a bit of German?
Yes.
Uh, I can just order a few things, and if they talk to me quite fluently, I'm gonna be like, wait, and just bring out Microsoft Translator. They did teach us German, but I don't know, it didn't really catch on.
Hmm.
Aufbau, what does that mean?
That's the name, no?
Exactly, it's to build things up. Yes, gradually. These are going to fill gradually according to energetics. Yes, 2p, 3s, 3p, 4s. After 4S, we have 3D. Why? Because it's in a higher energy state. Then 5S is going to fill up, and then afterwards will 4P be filled up because these orbitals and these subshells are going to be further away. So correct filling order is going to be the backbone of electron configuration. It's like how water pours down. It will fill up lower levels, and then it's going to fill up everything else. Why? A higher energy state means less comfort. Yes? Are you
Mhm.
standing or sitting right now?
Sitting,
Obviously. Why?
obviously.
Because it's comfortable.
Uh,
Yeah, you could be laying on your side or whatever, whatever's comfortable. Well, same thing applies to electrons, is they will try to achieve an energy minimum if possible.
hmm.
And oftentimes, yes, uh, 3D before 4S, yeah, oftentimes, if you write 3D before 4S, that's a no-no because 4S will fill up first and only afterwards 3D.
Hmm.
Usually, in order to not fail, I would just write up this table and just draw those lines, and then I would know and not make a mistake.
Hmm.
Same spin is not allowed. You probably have played billiards already. I'm not sure if you're a fan, but yeah. And have you played billiards?
Yes.
It's fun, isn't it?
Hmm.
I remember in the early 90s, it was a status symbol to have a billiard table in your home. Nobody played. In 10 years, they all forgot about it. In the 19th century, poets and usually artists would be champions at billiards. Heck, we even skipped school in order to play billiards. Now, if a ball is spinning in one direction, you hit it with another ball spinning in the same direction, it will gain enough momentum to fly off the table, which is a big no-no because these balls are usually hard, but they're brittle.
Hmm.
And usually where we would play billiards in these bars in the 90s and in the 80s, they would have soft, cushiony environments so the ball would not break.
Hmm.
Because not everyone was that well versed in playing billiards. Now,
Hmm.
if the spin was opposite, it would have an elastic interaction. It would just touch it and they would both fly apart, but the second ball would not fall off the table. We used to experiment with these. We also used to have championships. We would place bets because that's what we would see from adults. Well, these adults were in and out of prison, so not the best role models to go after, but yeah, they seemed cool, like the people from films. Bad idea, very bad idea. We also had an English teacher, Mr. Andrew. Mr. Andrew died of cocaine overdose.
Oh.
Very sad. We were in the second grade. It was so sad. Mr. Andrew was a lovely man. He gave us nicknames,
Hmm.
English nicknames. Yeah. He was great. I miss him
What was your
still.
nickname?
Mine was Billy.
Billy. Okay.
Yeah, but in Hungarian it's not the best choice. But it's in
Oh.
Hungarian it means chamber pot. So yeah, we would laugh about it. Have you had nicknames as in school in English class?
Uh, Not really. No.
Yeah, Chinese kids usually choose a nickname for
Yeah.
themselves because it's easier than pronouncing their whole name.
Uh-huh.
Yeah. In Hungary, in from Kőbánya, they like Tommy. They like Tommy a lot. Or
Tommy.
Tommy, Tamás.
Uh-huh.
A lot
Okay.
of them have themselves called Tamás. They have their Chinese name, of course, but yeah, I usually make an effort to learn their Chinese name.
Mm-hmm.
And yeah, it works out. Usually in about 6 months, I get it right.
Mm-hmm.
And they always laugh and smile, and they're like, "It's okay to call me Amanda." No, I have to learn it. I can hear the difference. I have to give you respect. And they're smiling about it, of course. I mean, yeah. I mean, I never expect my kids to learn my entire name. They're like, Laszlo, that's good enough. Yeah. Oh, we went to a sushi bar and turns out they were all Chinese, the servers, and locals couldn't tell that they were actually Chinese because Asian doesn't matter. I was like, you look awfully Chinese for a Japanese thing, and they're like, Laszlo, don't give me away. I'm one of your students, actually. I'm like, small world. But they do serve amazing food, by the way. It was just a bit of an oddity, yes.
Okay, okay.
They're good people. They're good people, and oftentimes they go with these nicknames because it's more adaptable. Yeah, I mean, if you have a Hungarian name, it may be difficult for others who don't know any Hungarians, no ever had to pronounce anything Hungarian. But oddly enough, in around 3 years, most Iranians learn Hungarian to an acceptable level. And
Uh-huh.
they do express themselves well, especially if they want to work in Hungarian healthcare.
Uh-huh.
I know a kid who finished medicine and now he's studying to be a paramedic on the Hungarian line of study.
Oh, okay.
I was baffled, and they're remarkably good professionals. So
Okay. Uh-huh.
now Hans Rule says that these will build up gradually. Yes,
Yes.
it's like one seat per person, and obviously this will not occur. I don't want a roommate. Make that fucker go in the other room and face the same direction as I do. Yeah,
Uh-huh.
that's what the Alba principle and Hans rule mean. Electrons are going to fill equal energy orbitals with parallel spins before pairing. Why? Because energetically it's more favored. It's more comfortable. Yeah.
Yes.
Uh, Yeah, pairing too soon may bring about wrong answers, and that's when I get those small heart attacks. Yeah, that's me if I wasn't fat. So at a later stage, pairing up will occur, but first,
Mhm. Pairing up will occur, but first, oh, they have to first fill the shells with the same spin.
spot on, perfect, perfectly executed, excellent. Electron configuration notation is going to occur gradually as well. First one fills up, second, third, fourth, and we know the exceptions, yes?
Yes.
And everyone's looking for that good old noble gas configuration. A noble gas configuration can be a duet
Yes.
or an octet.
Yes.
If you can't get a noble gas configuration, it's fine. You will settle for less if it's more comfortable. Yeah. Let's say I can't get an Aston Martin, so I'm going to drive a Lamborghini. Unlucky me. But it's an analogy to that. I mean, an Aston Martin is indeed beautiful, but I would not bring it to these Eastern European roads. And,
Yeah.
Yeah, it would get unpleasant attention from the wrong kind of people.
Yeah.
Unfortunately, we're not that civilized here. I don't think I have ever seen an Aston Martin in Eastern Europe, to be honest. Perhaps in certain regions in England, but yeah, it has to do with public safety and trust. If it's a high trust community with obviously law-abiding citizens, it's not an issue. Obviously, it's gonna grab some stares, but not envy in the form of let's damage this or whatnot. I remember someone just drove home to my hometown in a Ferrari, a convertible,
Yeah.
and yeah, it's pretty. It was a lovely car. We congratulated him, nice car, whatnot. Like people should.
Mm-hmm.
But someone was bad enough to cut the top open because it was made of
Oh,
fabric, just to be bad. And you know what? At those times, I feel ashamed on behalf of the community that we permit such people to exist.
yeah.
And I don't know who it was, but come on. Someone worked their butt off to be able to get that, and now you're damaging it out of spite, hate, and envy. And you know what? That person's never going to do anything with their lives. That's how they're going to end. But still, why ruin someone else's happiness? So, yeah, key takeaway, people can be jerks, but it doesn't characterize you, it characterizes them.
Yes.
And for them, it's forever because of mentality. Early configurations reveal the rules before the table gets big. Yeah, this is your second period, not that big. Then further on, you get neon. Neon is a noble gas. Yep. Fluorine has more and more and more electrons in the 2p subshell. And you pair after all equal energy p orbitals have been occupied. Yes. In the case of nitrogen, you don't pair things up. Those three electrons have equal valences.
Mm-hmm.
And what's missing? Nitrogen's missing
Nitrogen's missing.
an
Uh,
electron.
Election, yes.
Also, for some reason, it also gave oxygen. Oh, it gave it smaller electrons. I'm disappointed at it. But bottom line, Z is correct. It's just a representation. And of course, fluorine should have seven valence electrons, and neon uh, should have eight valence electrons, and of course, the whole orbital filled completely. Sodium and magnesium configurations obviously are going to define their place in the periodic table, and in order to achieve an octet, they're going to lose one or two electrons. The way they lose those electrons, of course, happens gradually. Chlorine would rather gain an electron than lose one because it's energetically more favorable, and it's a major extracellular anion. It contributes greatly to resting membrane potential in every cell. Halogens usually gain one electron because it's energetically favored. As they gain that one electron, their radius increases. If something loses one, then radius decreases. Calcium's going to lose those electrons in order to reach the closest noble gases electron configuration. I argued with the machine for so long in order to allow me to show that this is how I think when I think about cation and anion formation. How do I get the nearest noble gas configuration? Yes,
Mm-hmm.
and we don't use noble gas after the element. You might have the wrong electron count, far too early, have the same spin, write 3D before 4s. That's where I usually make mistakes.
Mm-hmm.
I've documented my mistakes from my high school notes. And yeah, wrong noble gas core. You can use a periodic table. Use it. Check capacity. Now, valence shell electrons, they're the outermost shells, and they are the ones that either going to power up or they're or it's in the case of seven valence electrons, chlorine minus in order to achieve an octet, it's going to gain an electron. Magnesium's going to lose its electrons, and
Mhm.
sodium's also going to lose its electron in order to get the closest stable electron configuration. Now, these are all paramount for health. A lot of Hungarian folk, especially elderly people with a not too balanced diet, they may be lacking magnesium and potassium. There's a thing called panangin, in Hungarian it's panangin. It contains magnesium and potassium and it helps them balance things out. If they take vitamin D and B vitamins with it, they're not going to feel as dumb as they did previously. They're lacking these vitamins because after a certain age, you lose appetite, you don't drink as much, and you stop with proper self-care. Big
Mhm.
mistake, big mistake. Main group valence electrons are they same as
Mm. One more time. Main group,
main group valence electrons are the same as
the group number.
the group number. Perfect. And of course, S, P, D, and F blocks, they're the last subshells to receive the differentiating electron. That's why we have these blocks, and they have a common behavior. D block elements are oftentimes transition metals. Not
Yes.
all of them are, but oftentimes F block elements can be rather rare. Some of them may be artificially made, and there are newer elements beyond this. This is just what is more common in nature because a lot of them are artificial elements nowadays, are bigger elements because of the low stability. First group elements lose one electron. Group 17 elements are going to gain an electron, and this is pretty much going to define their chemical behavior. Uh, P6 electron configuration means a fully filled outermost shell. Underneath that, you're obviously going to have an S2, and that all of them together are going to form an octet. But
Yes.
this is a far more accurate representation of what's going on. Now, as these ions form, obviously, if I lose an electron, my radius becomes smaller. If I gain an electron, my radius becomes bigger because there's a tug of war between electrons and protons. Obviously, opposites attract, and if I have more electrons, they can pull further away. If I have more protons, they're going to pull those electrons closer towards the nucleus.
Mhm.
This cation's positive trends obvious. Your muscles, your brain, your bones all need these ions. You need at least 1 gram of calcium from food per day. Can you get some of it from supplements? Yes, but drink up. Otherwise, if you take supplements, you take too many supplements, it can be an issue. If you drink mineral water, proper mineral water with high enough levels of calcium and magnesium, obviously it can supplement you properly. And oddly enough, hard water does not cause kidney stones. Over supplementation can give you a predisposition to kidney stones. I have a friend, he's 70 years old now. In his 20s, he had kidney stones, and the doctor told him to drink a beer time after time. Well, what do you think happens?
His kidney stones disappeared.
He hasn't had any kidney stones ever since, but now he's 70 years old. He has his pension, but he also is a night watchman in order to feed his habit of drinking 18 beers a day.
Oh my God.
I think it's his main calorie source. He's a great guy, I mind you, but I'm afraid that we will lose him. He's strong, he's honest, he's protective of his family and whatnot, protective of his community. I mean, a blind young lady said that someone touched her improperly in the bus stop. These elderly men, as soon as they found out, they stood up, found the guy, and beat the living shit out of him. Then called the police that they found him beaten up. Yeah, yeah, they're good men. And when obviously the criminal did not have the intelligence to press charges. If he would have, I would have sworn on the road that these men were actually drinking with me. I don't think. It's just kind of Yeah, but they're good people. They're good people. I mean, they have their own vices, but ultimately they do what's right. Yeah.
Uh,
Now, atomic radius, as you can see, versus ionic radius is measured in PM, picometers.
yes.
Sometimes we use angstroms. Angstrom is A and a
Yes.
little E. It's just going to be a dot here. It's 1.97, but picometers somehow it seems better. Angstroms is usually used by the Eastern Bloc countries. I
Mhm.
don't know why. And anions, they grow as they achieve their octets. And yeah, it appears, what's wrong here?
there is
Common
one
mistake.
more.
Exactly. The number of electrons don't check out. Always be careful about the number of electrons that they check out. In this case, obviously, it's true. And yeah, it does expand. It does expand, and fluorine cannot hold 9 electrons. So be careful of that. It is a common mistake that I also make, that I draw too many or
Mhm.
not enough. Always count them down. But this is just for written exams in uni, because in Moodle, you're just going to have to click a few things. It's going to be quite similar to the online tests that we're doing now.
Mhm.
Sodium chloride rehydration therapy has a cocktail of compounds in order to rehydrate the patient, because salt draws water and these ions have a layer of water around them.
Yes.
Transition metals can be D block elements, but they have a specific ion redox behavior, and the ions have specific color, specific magnetism, and may be involved in catalysis. Iron is very important, zinc is very important, copper is very important. We just don't put it in general basic chemistry. We should, but it's not yet recognized as much.
Mhm.
Shielding occurs because of spin. If an electric field is spinning, it will also have a what kind of field?
And magnetic field.
Spot on, and vice versa. You probably have heard of a dynamo as well. When a magnetic field is spinning, it's gonna make you electricity.
Yes.
A dynamo was oftentimes used as a little wheel linked to your big wheel on a bicycle, and then you would have a light going and you didn't need any batteries.
Mhm.
Old technology from the previous century. Nowadays it's not as common. Have you noticed it?
Yes.
Nowadays people have rechargeable batteries and they're not bothered, they're not phased by it. Great comfort. Now, the more shells you have, the greater the shielding effect is going to be. So the effective power of the nucleus to pull this electron towards itself is going to be greatly diminished. So the bigger the element, the first group element, the easier it's going to be for me to take away that outermost electron. But also, atomic radius from left to right, yeah, the charge itself and the effective charge is going to increase.
Mhm.
Hence, the atomic radius is going to become smaller and smaller and smaller as I move from left to right in the periodic table. This is a very important trend in the periodic table. Atomic radius reduces from left to right across the
Yes.
and there's more pull. There's more pull.
Mhm.
That's the thing. An ionic radius, on the other hand, in the case of a cation, it's going to be smaller. In the case of an anion, it's going to be bigger. Ionic size also affects solubility, channel permeation. Are you going to be able to cross a channel? Are you going to be able to bind to a protein, be absorbed, be distributed, excreted? It does matter.
Mhm.
And nuclear charge increases. Nuclear charge increases. And because of that, there's greater pull. Despite the fact that they're isoelectronic, basically they're the same number of electrons if you think about it, but because you have more protons, it's going to have a greater pull. It's going to have a greater pull, hence the radius decreases. It's a
Mhm.
tendency. Ionization energy is required to remove an electron, so I have to invest it. Obviously, in the case of metals, it's going to be small. In the case of non-metals, good luck with that. Same thing with noble gases, good luck with that. And it does define chemical identity. Electron affinity is also an energy. Oh, I got an electron. I'm so happy. I got my first electron. I'm so happy and so comfortable that I'm going to let off energy. It depends who I am. Because if I'm chlorine, if I'm oxygen, I'm gonna let off energy, but also then consume energy in the second electron affinity. In the case of neon, obviously, it's not gonna be favorable. I'm not gonna need any electrons right now. And
Mhm.
if you open the Stoker book, which I recommend doing, you're going to see trends in electronegativity, electron affinity, first, second, third ionization energy as well. It's a very good reference book. Chlorine has the highest electronegativity or the capacity to draw electrons towards itself. Second place belongs to oxygen. Third place belongs to chlorine, but nitrogen is quite good at it too. However, it's in the case of nitrogen, it's not as pronounced. Yes, relatively to fluorine, it's an electronegativity trend according to the 2020 to the 2006 polling scale, because any book that's been written before that is going to have a different thing, because um, uh, books written before 2000 oftentimes may reference francium as an electropositive element. And the
Mhm.
concept of electropositivity, there's no such thing. There's just little electronegativity. It's like I'm able to take candy from a baby because the baby's weak. That doesn't mean the baby gave me the candy. That's the whole analogy I make with this. And you'd be surprised. You'd be surprised. When I started teaching, the concept of electropositivity still existed in high school kids. They're good kids. They learned what they were told.
Mhm.
Atomic radius increases as you move towards metals. Ionic radius depends on the charge and the electron configuration, but cations small and ions big when they get bigger than the original atom. Electron affinity more negative and more towards the right. Oddly enough, there's a bit of a strange thing in electron affinity. Chlorine has greater electron affinity than fluorine, despite the fact that fluorine has higher electronegativity. What do you think the reason for it might be?
Mm, its placement, no, some kind of mm, I'm not sure.
If I fit, I sit. It's the whole cat strategy, yes?
Huh?
On fluorine, it's much more difficult to fit an electron. It wants it, but it's more difficult to fit because it's small.
Okay.
Chlorine's bigger, so its first electron affinity is a little bit bigger than that of fluorine. Otherwise, trends apply. Yeah, it's a bit of an oddity. You'll find this in greater detail in the Stoker book with explanations likewise. Some of them are biologically immensely important. Osmotic balance, resting membrane potential, and heart health. Yeah, people with a heart condition. Calcium, muscle contraction, cellular signaling, as important as ATP. Yeah.
Mhm.
Magnesium, very important, stabilizes ATP, helps you use ATP more effectively if you supplement with creatine. Of course, you don't take creatine the same time as you take magnesium because it will form a complex. I mean, you have to supplement yourself wisely and think about how you're going to use it. Chlorine comes together with salt. I mean, salt is not your enemy. 2 kilos of salt a day may be a tad bit too much, but it's not your enemy. If you're young and you manage salt well and you don't have high blood pressure, salt is not an issue. When you're older, if you gain weight, if you have issues with circulation, salt will affect your blood pressure negatively.
Mhm.
So it depends whom. And I probably told you the experiment. I gave salty snacks to my
Yes, yes.
kids, and yeah, actually, if you're more comfortable, your blood pressure and heart rate drops. So yeah,
Mhm.
ion gradients oftentimes may contribute to signaling. Magnesiums and ATP partner together with who helps you use ATP more effectively. It's
Uh,
a common supplement. Even if you pulled an all-nighter, you supplement hard on it and you're going to feel
Caffeine.
well. Creatine, indeed. Yes, yes, yes. By the way, I talk so much about creatine and I forget to take my creatine today. For shame, for shame. Preaching it and not doing it. I wish I would do everything I tell people they should do. But I try, I really try. I just forget about self-care sometimes. Don't do that. Don't do that. You deserve it. You should do it. It's perfectly fine. Copper is very important for ATP production because your mitochondria needs copper for its proper mitochondrial health. Oftentimes we don't see any negative effects or anyone missing copper, but it wasn't diagnosed yet as a deadly disease.
Mhm.
Iodine. We use it sparingly. It's for thyroid hormones because of its relative rarity in nature. And of course, if someone has some kind of thyroid issue, let's say there's a thyroid growth, oftentimes they're going to use an iodine radioisotope to damage it willingly, so there's no overproduction of thyroid hormones. If there's underproduction, then there's going to be supplementation of it. It's a complex thing. Every fifth woman in Hungary has some kind of thyroid issue, overproduction, underproduction, or post-COVID. The disease doesn't even have a name yet, and they need proper supplementation of thyroid hormones. Can we do it? Nowadays, yes, yes. Zinc, extremely important also for immunity, growth, and healing, and of course for alkalic phosphatase as well. So if you know someone lost a lot of water, they should immediately resupplement on zinc because they can get easily sick. There are multivitamins that contain minerals as well, and if they have a good track record of being absorbed, it's a good idea to supplement that. Yeah, supplements sometimes with vitamin C. Just don't go into any excess because any excess, for example, more than 2 grams of vitamin C may increase the likelihood of developing kidney stones in about a month. Does it mean everyone will get kidney stones? No, but people who are susceptible to it, maybe. Because saying a definite yes, that's risky. Yeah, but maybe possible. It's possible. It's not 100% sure, but it's possible. It's best to avoid it. Taking a gram of vitamin C a day, which is slowly absorbed, that's beneficial. That's great. It's an excellent antioxidant. There's nothing wrong with that. And always drink up, yeah, because many people forget to drink enough. Since the 90s, we all have our personal bottles of water. Um, it never hurts. Never hurts to have. I mean, you always drink up. You're doing everything right. There are a few drill questions. These are just for you. You can
Mhm.
put them on your tablet. You can draw on them. You have a PDF editor. That's perfectly right. A few takeaways and whatnot. And of course, a bit of an answer key with reasoning likewise, and a bit of a summary. Now, what we advise you to do is basically go through the whole Stalker book as well. There's a bit of extras here, each and every atomic model, just as a tad bit of expand your horizons. I don't think anyone is going to ask you about the Thomson Rutherford boron model, quantum mechanical model, but it's best to hear of it if some weird guy comes up. Of course, ground state, excited state, and photon transitions make a very important one because there's a relationship between levels, and obviously, if an electron comes from a higher level into its original level, energy level, it will emit a photon. That's how fireworks work. Yeah.
Yeah.
And sodium is a bit of an asshole. It suppresses everybody else. But yeah, fireworks I think are amazing because I'm
Mhm.
kind of a pyromaniac. So yes, I'm not an independent person in that remark. Um, of course, certain subshells may be allowed in comparison to each shell. and obviously there's going to be a letter map to that as well, which are permissible, which are not, how do they fill up, which electrons may have or may not have certain subshells. And of course, shielding is a very important thing. It shields the outermost electron from the effects of the nucleus oftentimes, and the more shielding electrons you got, the less likely it is for the electron to be on the great control of the nucleus. With the same shell orbital shape affects how close an electron can go to the nucleus, which changes, of course, penetration, shielding, and subshell energies as well. So it's kind of a complex thing. And of course, in the case of chromium and copper, there are a few exceptions because D5, D10, and D0 are far more stable. It's a small energy trade-off, but it adds extra stability. So they're kind of an exception in the case of electron configurations. This is a bit of an extra for D block elements. Um, I usually teach this in A levels. I'm not sure. I think IB since 2018 has been a tad bit reduced in this regard, but it's good to know. It's always good to
Mhm.
know the certain electron configurations, despite them not being an octet, may be rather stable. Ionization energies are successive. There's going to be a big jump. You're going to find this in greater detail in the Stoker book. But in the case of magnesium, first two electrons can be taken fairly easily. But then magnesium reaches an octet, and it has two extra protons in the nucleus. So taking the third electron, well, good luck with that. It's going to be an insanely high number, and that's the reason for it. It's because of the octet. And obviously, magnesium stabilizes ATP and acts as an enzyme cofactor. And first ionization energy does not determine common charge. Second ionization energy is still fairly possible. A third one will not occur because it's hindered. It's a big jump that requires a lot of energy and it won't happen on its own.
Mhm.
Paramagnetism, diamagnetism depends on electron configuration. Now, paramagnetism may also contribute to ferromagnetism. Ferromagnetism, yes.
Mhm.
Ferromagnetism means a magnet is able to attract it. It can be pulled into a magnetic field if there are two unpaired electrons in electron configuration. If they're perfectly paired, then there's not going to be any attraction. And of course, but paramagnetism may interfere NMR as well. So you have to make sure there's no metallic residue.
Mhm.
If everyone's paired up, it's diamagnetic, it's weakly repaired. If we have unpaired electrons, it can be paramagnetic. Paramagnetism doesn't always mean ferromagnetism. Ferromagnetism means it can be attracted by a magnet as a piece of iron. Yeah, ferro means yes. So yeah, and yes, nitrogen is also paramagnetic on its own if it's unbound.
Mhm.
And of course, we're not blinded by arrows. We kind of get that. I also covered the main trends. I tried to put everything from the Stoker book into this. And yes, shielding subshell energies, you understand those. Subshells have particular energies, and these build up gradually. And stability has to do with noble gas configuration or D0, D5, D10.
Mhm.
Mm, There's a bit of which one would not exist, and then how quantum numbers change as well. Yes, quantum numbers virtually define what kind of orbitals they have. There's an n. There's an L, there's an M, and an S quantum number as well. Principal, azimuthal, magnetic, and spin quantum number. And basically, all four quantum numbers in the same atom have to differ for each electron. That's the bottom line. You'll find greater detail in the book as well. The Aufbau principle says that lowest energy fills up first. Pauli says max 2 electrons per orbital, opposite spins, and no 2 electrons in the same atom can have the same four quantum numbers. Bottom line, yes. Principal quantum number shows me how far I'm from the nucleus. Yes. L quantum number, secondary quantum or azimuthal quantum number shows me the shape of the orbital. Magnetic quantum number, which part of that shape my electron is on, and the fourth quantum number, the spin quantum number, is going to tell me the spin of the electron. In
Mm-hmm.
which direction does it spin? Obviously, spin is kind of a three-dimensional word interpretation of quantum mechanics. But we say it spins in this or that reaction, direction. Magnesium successive ionization energy is easy peasy, a walk in the park. Yep, magnetism, which is diamagnetic, which is paramagnetic, easy. You know it has to do with electron pairing. And of course, atomic radius, ionization energy, shielding, easily justifiable, right? And here's a tad bit of a summary of it all. And of course, a bit of an interesting thing that, of course, hydrogen only has 1 electron. Yes. So it has the same energy. There's no splitting. There's not that many subshells. But if you have more electrons, then obviously more subshells are going to be possible.
Yes.
And it's just going to fill up gradually. And of course, the distance from the nucleus again varies, and there's a probability of distribution of electrons where they're going to be with a very high likelihood. Trends of attraction and of course, um, they also asked me why doesn't the electron fall into the nucleus because of attraction? Because it has its own magnetic field due to spinning.
Yes.
So it's unable to be completely pulled into the nucleus. That's what anatomy teachers asked me. Pauli rule, applying Hund rule, and yeah, just do a checklist of did I do everything correctly? Hopefully, yes. Isoelectric series, this is a reoccurring thing. They give you an isoelectric series and give them in the correct order of radii. Radius is going to decrease. The more protons you have in your nucleus, the smaller your radius is going to be. And this is why certain anions and cations fit through channels while others do not.
Mm-hmm.
Because it just doesn't fit. It is what it is. And yes, ions are encircled by water, by H3O pluses, because the water has its own ionization, by OH minuses, and it's a complex thing what's going on in an aqueous solution. With successive ionization, obviously, we understood why the third ionization energy is so difficult and what roles magnesium plays. We understood the logic behind the transition metals, why iron 2 plus and iron 3 plus are all possible. Yes, all of them have a relative stability, and 3 plus is so beloved because of this, because of the electron configuration, and hemoglobin can only transport oxygen and carbon dioxide if the central iron is iron 2. If it's
Mm-hmm.
oxidized, it's called methemoglobinemia, and you have to reduce it back. You can use methylene blue and ascorbic acid in an intravenous solution to reduce it back. Hydrogen's kind of a weird dude. It can be hydrogen plus hydrogen minus. It can act like a cation. It can act like an anion. Super weird dudes. And it does it despite the high levels of energy it needs to climb. And its positive charge is just a proton. It's going to contribute to pH. If it has a negative charge, it's called a hydride. And sodium and calcium hydride do exist. Are they stable? No. Are they ionic? Yes. Do they decompose on their own? They do not. Do they react with water? Hell yeah, they do, forming the appropriate hydroxide and hydrogen gas. Super reactive, super reactive. Yes.
Hmm.
But hydrogen, the little guy, is really flexible from a chemical perspective. As you can see, each group has its own little behavior, and yes, it's how how standard membrane potential is maintained. It's concentrations that are actively being kept this way. That's why we have these these standard membrane potentials. So yeah, it kind of makes things visible and puts them into perspective. Do you have access to the Google Drive? Are you
Yes.
able to download everything?
Mhm.
Have you gotten the new PDFs?
Yes, 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 I have.
Okay. Jó, rendben van. Hát én nagyon szépen köszönöm, hogy itt voltál, fölteszem a YouTube-ra ugyanúgy.